Hi Abhishek,
Hey Rohit, how are you doing?
I'm doing good. How are you?
Not too bad, thank you. Pretty hot here in Delhi right now, so yeah, live
Yeah,
from Delhi on a hot summer afternoon. Happy to be here.
yeah, I can totally understand.
Yeah.
So, before you, we had Kamesh and Arvind session.
Yeah.
So, we are really glad to have you as a speaker because this is the first time we are having you
Yeah.
associated with us. So, Abhishek, not wasting further more time, you can introduce about yourself and uh, what will be your topic, the session, so that we can
Sure.
start. Yeah.
Absolutely. So should I go ahead and share my screen if that's okay?
Sure. Yeah, yeah.
I'll do that then. Entire screen. All right.
I'm just
So
adding. Yeah.
mhm. Just let me know when you've added the screen and it's all set.
Shall I add now?
Yes, please.
Shall I add now?
Yes, Rohit.
Yeah.
Please go ahead.
Okay, cool. Here you
All
go.
right. Awesome. Uh, Cool, we're live. Awesome. So welcome everybody. Good morning, good afternoon, good evening to all of you, wherever you might be, including my wife and son, who I think are in the other room checking this out. Welcome to this session on Dapr, this open source project, which I'm going to talk about, which I think can potentially help you with building these distributed, cloud native microservices. A bit about myself. My name is Abhishek Gupta. I am a developer advocate at Microsoft. Here are my social media handles. I'm on Twitter and GitHub. Feel free to reach out to me on these channels. Currently, in terms of my role here at Microsoft, I tend to focus on a lot of distributed systems and distributed technologies like Kafka, NoSQL databases, Kubernetes, and a lot of open source projects, both like working on them, like from contribution and so on and so forth. And one of the projects is obviously Dapr and some of the other technologies which you probably saw a peek preview of. So Kamesh spoke about distributed Kafka clusters on Kubernetes using a project called Strimzy. So that is something which I also sort of am interested on and tend to work on, right? So that's it about me. What about you folks, and what about this talk, right? What is the agenda? Learn everything? Not really. Uh, you know, to be honest, what I want you folks to get out of this talk is, learn a little bit about Dapr at least, right? It's literally impossible to, learn a technology end to end in like a space of 40 to 45 minutes. Not possible. So I'm here to at least, make you curious and excite you if that's possible, and so that you can take some of the information and knowledge from this talk and go and check out Dapr and see how it can potentially solve your problems, or just play around with it, or maybe even contribute back, right? So I'm going to give you an overview, including the why and what of Dapr, and then I'm going to just cover a little bit of the hows of Dapr, dive in a little bit, and then it's going to be mostly demos. So hopefully a sort of 60-40 ratio there, and happy to hear your questions as well at the end, if that's okay. All right, so before I dive in, and now that I have your attention, everything is going to be available. This is essentially a short link to a GitHub repo where all the resources are there. I am going to sort of update it as we go along after this talk, but in the meanwhile, feel free to sort of take a note of this and screenshot whatever you feel comfortable with, right? So it's aka.ms of Dapr. All right. Having said that, let's dive in. So Dapr, like I said, it's an open source project for helping you build distributed microservices application, and it is relatively young. It was announced last year in October. It was obviously born here at Microsoft, and now of course it's a part of the bigger community, and it has picked up it has gained a lot of attention, and it's really has taken off since it got released. So it is a suite of projects, and of course, GitHub stars are not the only way to judge a project, but I really do want to highlight in terms of how popular it has become since it was open sourced, and in terms of both community uptake, community contributions, as well as real world scenarios. So we have sort of customers and who are sort of trying this, adopting this, and so on and so forth to solve real world problems. And one of the reasons I think it is becoming popular, at least, having spoken to the internal teams and a few of the developers, is the situation we have found ourselves in. When I say we, I mean we, the developers, right? What are our key requirements? We live in a cloud native world, right? And we are, sort of asked to build these best of breed, scalable cloud native applications, which have all the good properties, right? They have to scale to, I don't know, Google, Microsoft, and Amazon, scale and levels, although it's not required all the time. You can pick whatever language or whatever platform you want, right? The polyglot way of doing things. And shift from this monolithic application development style to distributed systems, to microservices. But the concern or the problems which have have come up with this trend is now that complexity has been now distributed from that one monolith application which you used to have to a bunch of different systems, right? And trust me, that's a huge problem for anyone who has built even, say, a suite of, say, 5 to 10 microservices, let alone like 100 or thousands, right? It's a problem which we, the developers, are facing. And to amplify that, to build on top of that, there are no dearth of options, right? So talk about cloud platforms. Like I said, GCP, Azure, Amazon, DigitalOcean, whatever, right? Talk about platforms. We have Kubernetes, right? It is the mother of all platforms. I like to call it the platform of platforms. And then you have much more focused platform as a services, systems, and CAS, which is container as a services, so on and so forth, right? And multiply these with other options, such as you can do this on cloud, you can do this on-prem, or in a hybrid fashion. And then think about your go-to application, your go-to development, favorite development language. It could be, for me, it is Java and Go. It could be .NET, Node.js, any Python for you folks, right? There are no dearth of options in terms of the frameworks which you can use. So Spring Boot, GoKit, MicroProfile, for those who have worked in the Java ecosystem at least, right? And not to forget all those other layers of technologies. I like to call them different concerns of running distributed systems. One of them is monitoring, logging, tracing, so on and so forth. So if you add these up, it's a complex system, to say, in a very simplified term, right? Can this be improved? Maybe not 100%, but let's try and see if something like Dapr can help simplify this for us, right? Let's just try and explore this idea. So let's try to understand Dapr. So Dapr actually stands for Distributed Application Runtime. And what I really want you to take out of this talk, if there is one single thing, try to understand that it is not a framework. Dapr is a runtime. So when I first started exploring Dapr and I saw, hey, it's a runtime, I immediately thought of, from my Java experience, I have worked on Java app servers for a long time, like WebLogic, JBoss, so on and so forth. They also are runtimes. Your applications runs within that managed, runtime, okay? But with Dapr, it is different. It is a runtime, but it has this sidecar architecture, and I'm going to talk about this sidecar architecture in detail in the next slide. So essentially what it is, that it's a component which runs alongside or along with your application. And the key problems which it solves is some of the things which you saw, those development concerns, things like persistence, things like distributed messaging within your applications, monitoring, tracing. So these application development concerns are abstracted from the developer and provided within Dapr in the form of components. So think of it like a buffet, and you can choose to eat pretty much whatever you like, or so that's the analogy I like to talk about. And it is not restricted to Kubernetes in any way, and I'm going to demonstrate that and talk about that a little bit. But Kubernetes is a first-class platform which is built which Dapr supports, from with the help of this operator pattern, which you saw even Arvind explaining, when he spoke about the entire Elasticsearch stack and how it runs on top of these operators. So here is like a 10,000 feet overview of Dapr. In the center, you have these things called components, like I just spoke about, and it really they are abstracted with these API layers. And these are the layers which you as the application developer have to worry about, right? So there is an HTTP API, pretty much ubiquitous with every platform and solution out there. There is a gRPC API, and on top of this, there are language-specific SDKs. So HTTP and gRPC is really language agnostic. Like pretty much any language which supports these, gRPC or HTTP can talk to the Dapr runtime. But you also have these language-specific SDKs for Go, Node, Python, or I think it's Go, Node, Python, Java, and even Rust, .NET as of now. And you can build, feel free to contribute other SDKs, right? And if you look at the bottom layer, really you can deploy it, on your local laptop as a standalone component within Kubernetes, pretty much anywhere, right? It has no affiliation, or it is not tied by the underlying infrastructure, of your which might power your applications. And like I said, these components are the core or the central fundamental tenets of Dapr. Some of these have been listed here. I'm going to talk about and cover, 3 or 4 of them. So there's the ability. So essentially, these components represents different features or capabilities of Dapr. So these are state management, distributed messaging, or using pub/sub, publish and subscribe. There is the ability to do triggers and bindings. It gives you first-class supports for secrets, so on and so forth. And I'm going to dive into this later, so I'm not going to spend too much time on this slide. But just for you to understand that these components really represent different features or capabilities which Dapr provides you, as an application developer. Like I was talking about the sidecar architecture, it's really it's non-invasive in a sense that your application does not run within Dapr, or Dapr does not control your application. It simply runs alongside your application, right? So here is an application code which can interface with this Dapr core runtime over an API using an SDK, and all these capabilities, these components which I just spoke about, are available to you. That's it, right? And from it's like the external the applications themselves are totally agnostic or unaware of the backend components. So for example, you might be using a Kafka cluster as your messaging subsystem, which Dapr integrates with, but your application is not going to know that it is talking to Kafka. It can just configure itself to talk to a Kafka endpoint, just to give you an example. And I'm going to obviously demonstrate this to you as well, right? So this is another fundamental tenet, the sidecar architecture, the non-invasive way in which Dapr is really modeled to help you with your application development. How does it operate, right? So like I said, Dapr has, it has a couple of modes. You can run it on your laptop in what we tend to call as the local or standalone mode. So really what it does is, like I was saying, it runs alongside your application. Your application only talks to the Dapr process or the Dapr sidecar process. And it is up to Dapr to really do the heavy lifting of things like storing states in key value stores, interacting with pub/sub messaging systems, storing secrets, triggering external systems, or getting triggered by external systems using bindings, so on and so forth, right? So this is a very simplified model of how you can use Dapr, in a standalone mode or isolated fashion. But really what we see Dapr is really popular is because of its first-class Kubernetes support. So things are a little different when you run Dapr on Kubernetes. I'm going to show this as a demo, but just to give you a high-level overview, when you run Dapr on Kubernetes, from an infrastructure perspective, it really runs as these multiple pods. So you see these blue pods right here. So you have different pods which execute different functionalities within the higher level Dapr system. Right, so you have an actor pod, you have a sidecar injector, and I'm going to talk about this as well. You have a sentry pod, and you have this operator which sort of takes care of, or it's continuously listening to whatever components you create within Kubernetes, and then it can update your application in response to that, right? So essentially what I want to highlight here is that really there's this suite of pods which coordinate together to offer you this all the capabilities which Dapr has as on Kubernetes in a distributed manner. And your application, in the meantime, runs as standard Kubernetes component, right? Typically, they are deployments. You can have jobs or anything of which can represent an application on Kubernetes for that matter, right? Of course, deployment is one popular way of doing it, right? And you will have a Dapr sidecar running within that pod, like I said, alongside your application code. So we'll see that in a demo pretty soon. So let me move on. And now I'm going to talk about some of the Dapr components. I cannot cover everything. And also, I would request you to sort of, if you want, just keep pace with some of the new components which are being added. So it's a pretty active project. But I'm going to cover 3 to 4 components here. I'll start off with Statestore, one of my favorite components. I'm a little biased as well because I've written a few of these as well myself. So I really enjoy talking about this and sort of working with the Statestore component. So really what Statestore component is, beneath the hood, Dapr supports a variety of key value stores. So, it's important for you to understand that these are key value stores and not any database, at least not as of now. In the future, there might be support for SQL databases, so on and so forth. So right now, just to give you an example, Dapr supports Redis, Azure Cosmos DB, Consul, etcd, right? And a bunch of other key value stores. When you talk about databases and application level concerns, when they interact with these databases, some of the key things or properties which we tend to discuss is concurrency, consistency levels, and things like that, and how your application is affected by that. So the way Dapr makes this sort of easy is by defining these, the Statestore specification, for example, right? So there are a list of, concurrency levels which Dapr supports, which your Statestore implementation can sort of buy into, right? And say, hey, this is the levels of concurrency, or these are the types of concurrency I'm going to support as far as the integration with Dapr is concerned, right? So we tend to call it optimistic concurrency control, right? It is done using e-tags in this case with Dapr. And then there are consistency levels, right? So it's sort of a spectrum, right? So Dapr supports both, one side of the spectrum where, it's strong consistency, potentially all your, if not all, at least, it has a quorum level agreement on whether the reads and writes have been successful or not. Or your Statestore can support eventual consistency, stating, hey, if you write to a Statestore using Dapr, eventually it will show up, but you cannot be, it's not like linearizable, if you tend to call it, right? You cannot immediately read your own write, right? So, but that's, an eventual consistency sort of concept, right? So that's that. Beneath the hood, it also sort of defines these retry policies, right? Linear and exponential, and how Dapr might sort of try and go about retrying all your failed operations. For example, a write operation failed, right? You can configure your application using the Dapr component rather. To say, hey, I want to apply exponential retries for this application, and so on and so forth. And last but not the least, your Statestore implementation can actually support transactional operations or batch operations. It's or both for that matter, right? So it really depends upon what kind of data store you are sort of implementing within Dapr, and depending on that, you can expect different levels of compatibilities and guarantees in terms of not only bulk operations, but all these parameters which I just spoke about. So concurrency, consistency, retries, and so on and so forth, right? So that's that in terms of Statestores. Another very, very popular component and one of my other favorites is bindings. Now, so when you think about bindings, think about the ability for your applications to be able to respond to external triggers, and those are typically called input bindings, as well as talk to external systems using output bindings. So essentially, these bindings are bidirectional in nature. Now, not all of the bindings are bidirectional. It really depends upon which binding you are using within Dapr. So there's Kafka, event hubs, blob storage, things like that, which are sort of bidirectional. But then there are other bindings which I know for sure are sort of unidirectional, right? So these are very event-driven. So if you think about event-driven systems, think about functions or serverless applications which really embrace this event-driven compute sort of fundamental, and sort of invoke your applications only when something is happening, right? So think of those concepts when you want to try and understand and envision what Dapr bindings are. Right? And like I said, there are multiple kinds of systems which Dapr supports in the form of bindings, which are storage systems, S3, GCP, Blob Store, Azure Blob, and lots of databases, as well as messaging systems. So you might, at this point, if you've been paying attention, you might say to yourself, "Hey, I just saw Abhishek talking about state stores, and how you can use databases as state stores." But then really, they are applicable and can work as bindings as well. So DynamoDB and Azure Cosmos DB are a few examples. So if you drop something into Cosmos DB, for example, and you've configured that as an input binding within Dapr, your code will be triggered via Dapr in response to something, an event or action which has taken place within an Azure Cosmos DB collection or container. Dapr PubSub, another favorite of mine. I know I have a lot of favorites. So really, PubSub is all about inter-application messaging, right? So it might sound very similar to bindings, but really bindings are for you to interact with external systems, as opposed to PubSub messaging component within Dapr, which is really meant for your different Dapr applications, Dapr A, to communicate in an asynchronous manner and in a decoupled manner with applications A, B, and C. Right, so that's inter-application, messaging. At the lowest level, Dapr guarantees, at least once, messaging guarantee, right? But obviously, depending upon which kind of messaging system you are working with behind the scenes with Dapr, really that messaging system can obviously provide elevated levels of guarantees, right? So exactly once, which is sort of a well, it's hard. Theoretically, it's possible, but practically, it's very difficult. Exactly once, or and things like that, right? So really what happens is that underneath the hood, Dapr takes care of interacting with these different messaging systems like Redis streams, NATs, service bus, etc. So these are sort of built into Dapr as of now, and help orchestrate or flow these messages between different Dapr applications. And I do want to highlight that although the name of the component is called PubSub, it's actually a little bit more than PubSub. Think of it as a distributed messaging component, right? So strictly speaking, PubSub is like this broadcast system where you have this, you have these subscribers, and all of them, get the messages which are sent to a specific centralized hub. That's not the case with Dapr. It really depends upon which PubSub system you're working with. It can be in a queue mode or in a pure PubSub mode, so on and so forth. So I just want you to understand that. Don't let the name sort of misguide you. I know it can be a little confusing. And finally, I'm going to talk to you about the secret store component. Obviously, it is meant to integrate with various secret stores. Kubernetes supports them through a first-class resource called secrets. Dapr also integrates with other external components such as Key Vault, Azure Key Vault, AWS Secret Manager, so on and so forth. And really, these secret stores are meant to work in conjunction with the different components. So here, what you see right now in this picture here is a component which is a state store, but see how it is using a Kubernetes secret behind, within itself to store the Redis password in this case, right? So in this snapshot here, you see the example of a Kubernetes secret, but like I said, it could be any of the supported key stores or secret stores within Dapr, such as Key Vault or AWS, so on and so forth, right? So that's that. How are we doing on time? Not bad. We have a few minutes. So like I said, and I spoke about these before. I touched upon some of these benefits, but I do want to highlight this to you, that all these components are sort of built into the runtime itself. They are just available out of the box, and any of the future components which will be developed and built will be available in the same manner, right? So you have the single binary, single Dapr runtime, and all these capabilities which are available to you, right? And I told you this before, your application is going to be completely unaware. It is not going to interact with these external systems, these data stores like Redis, these messaging systems like Kafka, NATS, so on and so forth, right? And all this results in portability. So you have, say, a dev scenario, right? Or these demos, which I'm going to do, right? I'm going to do them with a certain configuration, but then you can elevate these applications to a test environment or to production, and all you really do is change the configuration. And it's not just about dev, test, and production. It could be running on your laptop to running on full-fledged Kubernetes cluster, right? So that's the promise of portability which Dapr provides, right? And I really encourage you to go back, just explore Dapr, explore some of the other interesting components like service discovery, service invocation, actors, monitoring, distributed tracing. There's just so many. I cannot cover them within like 30-40 minutes. It's impossible. So I really encourage you to go check it out. And I will share some of the resources, obviously, at the end of this talk. Cool, it's time for demos. And let me quickly sip some water before that. All right, awesome. With that said, I'm going to switch to VS Code. So before I dive into any demo, let me quickly show you like what Dapr is, right? So I've opened up a terminal here. Really, what Dapr is that, so I'm going to interact with something called DAPR. This is a CLI. This is a Dapr CLI. This is not the runtime. This is not the core Dapr binary I was previously referring to. This is just a CLI, and it's very simple to install this on your laptop. Literally a single command. If you go to github.com/dapr/CLI, the project, and you'll see instructions, right? So I already have it installed. If I were to say, just print out the help commands, you will see that it has a bunch of, commands right here. So one of them is the init command, right? So if I were to do, hey, Dapr init, I'm not going to, run this right now because I already have it installed and I don't want to waste time. So you can, run it in a standalone or, sort of local mode, or a single command to run Dapr on Kubernetes, right? All you need to do is add this additional flag, right? So once you have the Dapr CLI, you can install Dapr, the core Dapr runtime, right? And what does that look like? If let me show this to you, right? So where is it installed? Then grab Dapr. So you see, right? I installed so you can ignore this part. This is like something else. So if you see this, I installed this yesterday. So the Dapr CLI is something which I just used, DAPR, and this is the core Dapr runtime, which is called Dapr D. And that's pretty much it, right? You have a single binary for everything. Okay. Now I already have Dapr installed. So this was my local machine. I already have Dapr installed on my Minikube cluster as well. So let me show that to you. So kubectl get. Let me show you pods, right? So if you see, I hope this is big enough. So you see, if you remember the diagram I was talking about, I was alluding to earlier. So Dapr is running in forms of these individual pods, and these sort of coordinate and collaborate with each other to give you that complete Dapr experience, right? So you have the operator pod, placement, sentry, and sidecar injector. And I'm going to obviously demo all these things to you in a little bit, right? Okay. So with that said, let me move on to my first demo. Now, what I'm going to show you is a pub sub capability, which I just spoke about using NATS. Now, for those of you who might not be familiar, NATS is a cloud native open source messaging system, which is also a part of the CNCF or Cloud Native Cloud Foundation. So check out, I'm just typing this out for you, nats.io, if you're interested, right? So, okay. So I'm going to show you the pub/sub NATS component running locally with Dapr on my machine. Okay, so let me quickly talk to you about some of the configuration related bits so you can relate to whatever I was talking about. So within Dapr, every capability which you want to use is represented by something called a component, right? I spoke to you about messaging, state stores, etc. So the same thing here. So in this case, the component happens to be pub/sub, and I'm using NATS to be very specific. And all this metadata is specific to the component. And this is different for different pub/sub systems. You will see that it's different for Kafka and different for NATS, right? So I am going to point to this publicly available, very handy for demos, like this NATS server, which is available right here. Okay, so this is the component right here. And I'm going to open this cheat sheet, which I'm going to use in a bit. So this is the component, and this is actually the application which is going to make use of this component. So I'm going to walk through this real quick. This is a Go application. Don't worry if you're not a Go developer. The concept is more important to understand, right? So because this is a pub/sub system, I have defined, so within my application, I have defined these HTTP endpoints. So what Dapr is going to do, once I start up the entire subsystem with Dapr and the application, Dapr will actually invoke this endpoint of mine, okay? And what I am doing right here is replying to Dapr saying, hey, my application wants to subscribe to this topic or to this pub/sub system. In case of NATS, it's called a subject, okay? That's that. And this part is what my application really wants to do when a message is sent to NATS, right? And then Dapr is going to funnel this from NATS and invoke this endpoint of my application, and I can choose to do whatever I want to do within this endpoint implementation, so to speak, right? So we are working with NATS, which is a messaging system, but see, there is no reference. My application does not know anything about NATS. There are no SDKs, no dependencies. Of course, I have to figure out what I want to do with that NATS message, right? But that's the real beauty here, okay? So I'm going to start off by quickly showing this to you, and this is all available on GitHub. I'm going to copy paste here just for the just to make this real quick. Export a few environment variables and see. This is the Dapr run command. So what I'm giving my app an ID. This is the Dapr port, not my application port. My application port is 8080. This is where my HTTP server is going to listen at. And I have said, hey, look here for the components, in this case, the NATS pub/sub components. And this is really coming back to the point of Dapr runs alongside your app. So I'm telling Dapr to execute this command, which in this case will run my Go application. And let me, oh, sorry, I should have CD'd into that. Yeah, there you go. So yeah, boom. So right now, if you see, these were some of the output, STD outs from the application. So HTTP server is running, and my application has started, listening to it. Subscribed to a subject called demo and this is the name of the subject itself. Right now, if I were to open another window and publish, so this is a subscriber application, and there is something called a Dapr publish command right here. This is just for ease of use. So this actually, if I were to do it a help, so it publishes an event to multiple consumers. So in this case, if I were to say, hey, Dapr, publish this to a topic called demo, and my payload is CC days. Okay. Now the name of the topic here is important because my application is subscribed to this demo topic. So you see, right? The event was published. So this is actually inter-application messaging in action, right? So this could obviously potentially be, I'm showing you this through CLI, but this could be a different application which can actually send messages to the Dapr sidecar, right? This is the Dapr runtime and not really a direct way of messaging. So you see, right? This was a cloud event payload which was sent all the way from NATS to Dapr to your application, right? And this is the data which we sent. Where is it? Okay, CC days here, right? So, and this is like a filtered sort of a more clearer way of looking this, right? So my event source was NATS app. That is nothing but the name of the application, our application ID, and this was the data. I can continue doing this, right? CC days online and it will work fine. So just FYI, this is coming to you all the way from NATS here, this public NATS server. If I were to click on this connections, if I were to scroll down real quick, so this is us actually, I'm pretty sure. So if you see, we have sent like 2 messages of now, as of now, you see in messages here. Just want to make sure that this is live and this is happening. So if I were to publish another message here, right, and refresh this real quick, you will see that in messages we sent 3 messages and received 3 messages, right? So see the beauty here. All the way from this command line right here to public internet, back to Dapr and to our application, right? So this is the entire system, and your application does not know anything about NATS, right? All right, cool. This was a very quick demo of PubSub. Now let me move on to another demo, which is going to show you bindings using Kafka. And I'm using Azure Event Hubs as my Kafka cluster here, but you could use anything, doesn't really matter. So just like before, I'm going to walk you through the component definition real quick, because I think this is important. So you see, like I said, this is a bindings component. What you just saw was a PubSub component. So it is a Kafka binding. And again, the metadata or the information specific to this component is, hey, which Kafka broker am I talking to? What is the password? Is the authentication required? So you can talk to like a local cluster which does not require any authentication, and that's fine as well. You can say false and not include the username and password. And which topic am I going to talk to, and so on and so forth, right? So this is what this component really defines. And now let me show this to you in action real quick. And I'm going to open my cheat sheet. And yeah, not to forget the application. It is very similar to the other one. Just in this case, you are talking or you are interacting with a Dapr binding component and not a PubSub component, right? So let me show this to you real quick. So I'm going to do this here, export the environment variables, and again the same drill, run this application. Okay, so in a bit it should be up and running. Okay, so you are up and running, and if I were to now quickly start off a producer application, which I have right here, again. I'm a little biased on Go. So I have written a producer application. Now what this is going to do is this is going to push events or messages to my Azure Event Hubs cluster on the cloud, okay? And then again, the entire flow is going to sort of complete end to end, right? So let me sort of show this to you real quick. So I have a handy script right here, start producer.sh. And once I kick it off, hopefully you should sort of see how this is working in tandem. So okay, send the message. Okay, so the producer right now is sending these messages to an Azure Event Hubs cluster on the cloud. If I were to quickly show this to you, just to make sure that that this is happening and this is real. Event Hubs. So this is the Event Hubs cluster which I'm working with. And if I were to quickly look at the messages, I'm not sure if it'll show up right now. Yeah, it hasn't. The number of messages for the last 1 hour, it hasn't, but trust me, it is working end to end. So all the way, this application right here is sending all these events to Event Hubs on the cloud, and to all the way to Dapr, which is being funneled to your application, the subscriber, or rather in this case, the bindings consumer, which is simply just logging this out to standard out as of now, just to showcase this in a very, very, very simple way. Let me go back and try and refresh this once again. I'm sort of hell-bent on this, but nope, it doesn't show up. It's okay. That's fine. All right, so that's it in terms of the local demos, right? Demos which run, which use Dapr on my local system. Let me hop over to Kubernetes-based demo. All right, so like I told you, I'm going to switch over to another demo right now. So now what I'm going to show you is the same demo working with Azure Event Hubs, a Kafka endpoint on Azure Event Hubs. But my application, the bindings, the Dapr application is going to be deployed to Kubernetes, and as well as this Dapr component, right? So excuse me. So this is my application right here. Like I said earlier, it is just another Kubernetes deployment, okay? But the important bit is this. So using these simple annotations, I have actually activated Dapr for this application, right? So you see this Dapr IO/enabled annotation. So that's going to work. That's the major trick involved here, right? The rest of these are important metadata for my application as well. This is running off of a Docker container, which I already have upon Docker Hub. So you can try this as well, of course, right? And just to show you the component, the cool part is that this has not changed at all. It is the same component which we had configured for the local application, which I just showed you, right? So there is no change. But if I create this on Kubernetes now, you will see how Dapr reacts to it, right? So I'm going to show that to you real quick here. Read me my nice little cheat sheet and back to my terminal. So I'm going to deploy this component to Kubernetes right now. So let me show you this to begin with. I don't have any components right now. You see, no Dapr components in Kubernetes. If I were to deploy this component, so you see this component was created, and if I run this command again, hey, I see a Kafka input component within Kubernetes. Now remember, this is created as a custom resource, a custom managed component within Kubernetes, and which component within Dapr was responsible for this actually happening was this operator. So this operator responds to any of the components which you might create, update, or delete, and sort of make sure that Kubernetes is sort of in sync with what you want to represent with your Dapr components, right? So this was just the component. This is just to say that, hey, I want this component within Kubernetes to be activated for my Dapr application. Now let me deploy the application itself. Okay, just a simple deployment. That's it, right? So if I were to quickly check this, so this is in the container creating state right now, and this should be up and running real quick. Notice here that this is one pod, but there are two containers running here. Okay, one is the Dapr sidecar, and the other one is your application, right? So that's the important concept here. Oopsie, 1 second. So I'm going to try and show you the logs here and show you the outputs from different components. So logs, the pod, and one of the components is the Dapr D. This is actually the Dapr sidecar, right? So these are the logs from the Dapr sidecar component. And what is the other container? We have the Kafka app container. So this comes from the name of the container which we just provided in our deployment.yaml file. And I'm going to tail the logs. Don't worry about this error message. This is completely harmless, right? So right now we are in a state where we have tailed the logs from our Kafka binding consumer application running on Kubernetes. Okay. Now let me do the same thing here. I will start the same producer applications. There is no difference whatsoever. Okay. And see how the application on Kubernetes also works in the same way, right? So you see message sent, message received, all hunky-dory, right? So you see how easy it was. At least to me, it is very easy. You deployed the same component definition within Kubernetes. You deployed your application. Instead of deploying this on your local machine, you deployed it as a deployment. It is running in a pod within Kubernetes, and you are using the same client application to produce events to your external system, which is Azure Event Hubs Kafka in this case, and your application is working on Kubernetes. But there is one last trick which I want to really demonstrate to you, and for that I apologize for so many windows, but I'm going to do that right here. So what I'm going to do is scale out these applications. So I'm going to start running two replicas. Right? This is simply scaling out your application from one pod to two pods now. Okay. So quickly copy, just to be quick and dirty, I'm going to copy paste this command which says, hey, scale out my deployment to 2 replicas. If I were to check out the pods right now, kubectl get pods, you will see that there is another pod which is running 11 seconds. It has just started. And what I'm going to do is start tailing logs from here as well and show you what's happening behind the scenes. So minus C Kafka app. If you notice now, really carefully, now all the messages are being actually balanced between this initial, the first instance and this instance. So not every message which is being sent via the producer is being received by both of them, because this is like a distributed messaging. This is like a queue thing, or a queue-based consumer application. With the more you scale it out, the more number of the more the ability to be able to distribute the number of messages within different applications. And of course, this is limited by other constraints, such as the number of partitions on your Kafka topics, but I'm not going to get into that. Really, the point I wanted to highlight here is the simplicity. Again, I'm going to harp upon this again and again. The point really is that you ran the same component within your Kubernetes systems. You ran the same producer application. You just deployed your application, consumer application in Kubernetes. You scaled it out. Everything works the same, right? So that's really the beauty of this system, right? Yeah, and something which I really hope you take away from these demos here. I'm going to simply close this for a while and also close this producer application and hop over to my presentation. So that's it. That's all I had in terms of the theory and some of the hands-on walkthroughs and demos. Now, what can you do next, right? Please do check out this link right here. I keep on highlighting this, aka.ms/tour of Dapr, because it has a bunch of resources. So download this presentation, and these are available. You can simply click on these links. So get started with Dapr, right? If you want to, just test the waters, so to speak. Then I would recommend just reading the document, right? Go through the concepts and so on and so forth. Try some of the samples. Join our community. There are so many ways you can, ask questions on Gitter, follow us on Twitter, or join our community calls, which happens once every 2 weeks. And the best thing is come and contribute components, improve the Dapr runtime, improve the CLI. Like I said, Dapr is a suite of projects. It's not one single project, right? So that's all I had. I hope you enjoyed this, and thank you very much. I really appreciate your attention, and I'm open for questions if there are any.
Thanks a lot, Abhishek. That was really cool, and the demo seemed to be really cool. Like, there are a bunch of questions we have, so I'll just quickly show the questions. And also, I would like to mention, like after this session, could you please share your presentation slide link and the resources? Yeah,
Absolutely.
you can share it in the private chat so that I can share it quickly with the audience. Cool.
Will do.
So
Absolutely.
I'll show the questions one by one. So there is the first question by